Sand dunes cover the landscape. It is arid, and there is only extremely sparse vegetation. It is a sunny day, and a small Velociraptor speeds through the scorching dunes. Ripples form in the sand, with waves enveloping our protagonist. He spots a medium-sized Protoceratops in proximity. Capable of detecting a wide range of sound frequencies, Velociraptor finds it easy to track prey. It seems like an opportune moment to ambush the unfortunate prey. The Velociraptor gets closer and closer until the Protoceratops spots him and brawls in an attempt to survive. Its large neck frill proves advantageous as they tug and fumble amidst the dunes. However, a sandstorm is approaching, and focused on surviving, both forget the inevitable threat that may lead to their death. This feathered carnivore is attempting to pierce the neck of the Protoceratops with its enlarged sickle-shaped claw. However, the sandstorm envelops them, and they are frozen in history, a snapshot of Mongolia roughly 70 million years ago. This scenario might have in fact occurred for the fighting dinosaur specimen discovered in 1971 that preserves a Velociraptor and Protoceratops locked in combat, a specimen we will cover in this video. Hi, welcome to Enchiridion. I am honored to share with you these facts on Velociraptor on a legendary episode of Dinosaurs Unearthed. Velociraptor was a dromaeosaurid, part of a group of bird-like dinosaurs known for possessing feathers. As a theropod dinosaur, it dwelled roughly 75 to 71 million years ago, during the Late Cretaceous period in Mongolia, East Asia. Smaller than other dromaeosaurids like Achillobator and Deinonychus, dinosaurs that would in reality be impressive and majestic given their interesting characteristics and adaptations. Velociraptor nonetheless shared many of the same anatomical features. It was a bipedal feathered carnivore with a long feathered tail and an enlarged sickle-shaped claw on each hindfoot, which it employed as part of its predatory repertoire. Velociraptor can be distinguished from other dromaeosaurids by its long, rather thin and low skull with an upturned snout. Velociraptor, also known as a raptor, is one of the dinosaurs most familiar to the general public due to how it was featured in Jurassic Park and its sequels. A scaly, reptilian and speeding monster that hunted in packs. However, scientific evidence begs to differ. In real life, Velociraptor was actually the size of a turkey, a lot smaller than the roughly 6.5 feet or 2 meter tall and 180 pound or 80 kilogram reptiles seen in the films, which were based on members of the related genus Deinonychus and a mashup of other dromaeosaurids, leading to lots of artistic license. Today, Velociraptor is well known to paleontologists in terms of anatomy, behavior, and lifestyle, with over a dozen described fossil skeletons, the most of any dromaeosaurid. This means Velociraptor is an incredibly valuable discovery that aids in not only research for one species, but also to a whole variety of other creatures through phylogeny and comparative similarities. Velociraptor was a lightweight bipedal hunter built for speed. Its skull was packed with roughly 15 small teeth in each jaw, suitable for taking meat off a carcass, yet not adapted for killing prey as in many other predatory theropods. As opposed to using the stereotypical hunting method of the killing bite or the stereotypical slashing motion portrayed in popular culture, odds are Velociraptor would instead have used the sickle-shaped claws that it had on the second toe of each foot to pierce the soft tissue at the neck, possibly to stab the area of the trachea, the vital carotid arteries, or the jugular vein, transporting a key blood supply between the brain and the heart. A stab piercing any of these two veins would surely lead to the death of the unfortunate prey in a few minutes. The small Velociraptor, victorious, amidst a new, sizable meal. While sharp at the point, along the inner curve they were rather weak, something that shows they were not used for slashing. This means these were not used to disembowel prey. Moreover, one particularly famous specimen preserves a Velociraptor locked in combat with a Protoceratops, the fighting dinosaur specimen. Analysis of this specimen shows that the claw was being used to stab at the neck, a considerably weak and vulnerable area, further providing evidence of the claw's actual function. This significant fossil also provides direct evidence of predatory behavior in Velociraptor and non-avian theropods. The hands of Velociraptor were large and may have been used for grabbing onto prey. The tail had a special series of tendons that kept it stiffened and erect, though there is also evidence for the tail being flexible. This would have provided a crucial form of balance when running and speeding through the desert dunes. Examination of the scleral rings has led to comparisons with modern birds that are nocturnal, and scientists believe this may possibly be evidence for a nocturnal lifestyle for Velociraptor. At night, temperatures in the deserts where it dwelled may have become much colder, and Velociraptor would have essentially been a tiny terror and beautiful wonder, with the moonlight shining on its possibly flamboyant feathers. To learn more about the paleobiology of Velociraptor, we must first understand the findings that led to these crucial insights. The year was 1923. American Museum of Natural History scientists were heading to an expedition to the outer Mongolian Gobi Desert on August 11th. It was a success, with Peter Kaysen recovering the first Velociraptor fossil known to science, a crushed yet complete skull, associated with one of the raptorial second toe claws, AMNH 6515. In addition, 3 remarkable new types of small theropod dinosaurs were discovered, in roughly the same geologic age, the Late Cretaceous. These included Velociraptor, the swift Caesar, Sauronithoides, the bird-like lizard, and Oviraptor, the egg thief, all crucial finds that proved to be valuable to research and expeditions in the Gobi Desert. In 1924, Museum President Henry Fairfield Osborn assigned the skull and claw, which he mistakenly assumes to come from the hand, as the type specimen of his new genus, Velociraptor. The claw was then found to be pertaining to the hindfoot. Osborn named the type species Velociraptor mongoliensis as homage to its country of origin. Earlier that year, Osborn had mentioned the animal in a popular press article under the name Oviraptor jedoctori, a genus separate from Oviraptor. Nonetheless, because the name Oviraptor was not published in a scientific journal or accompanied by a formal description, it was considered a nomen nudum, or naked name, and we were left with Velociraptor. This name, so unique, would be one chosen by Michael Crichton during his creation of the novel Jurassic Park, rather than Deinonychus as basis for his writing. At the height of the Cold War, North American teams of scientists were shut out of communist Mongolia. However, this did not lead to complete stagnation in discoveries, as expeditions by Soviet and Polish scientists, in collaboration with Mongolian colleagues, recovered several more specimens of Velociraptor. This proves the power of collaboration in the field of paleontology and how it can bring about many possibilities. The most famous specimen was preserved in the fighting dinosaur specimen, GIN 125, discovered by a Polish Mongolian team in 1971. This fossil preserves a Velociraptor in battle against a Protoceratops, a snapshot millions of years old, and one rather insightful. This specimen is considered to be a national treasure of Mongolia, and in the year 2000, it was loaned to the American Museum of Natural History in New York City for a temporary exhibition. It hails from the Late Cretaceous Jedoctor Formation of Mongolia. Collaboration proves effective. Between 1988 and 1990, a joint Chinese-Canadian team discovered Velociraptor remains in northern China, specifically the Bayan-Mandahu redbeds and the Jedoctor Formation of Mongolia. Luckily, the limitations imposed on American scientists due to the Cold War gradually dissolved, and these returned to Mongolia in 1990. Another joint Mongolian-American expedition to the Gobi, led by the American Museum of Natural History and the Mongolian Academy of Sciences, led to the discovery of various valuable, well-preserved skeletons that enriched our understanding of Velociraptor and other dromaeosaurids. IGM 100-980, one of the specimens, was nicknamed Ichabod Craniosaurus by Norell's team, given the fairly complete specimen was discovered without its skull, an allusion to the Washington Irving character Ichabod Crane. However, scientists identified this specimen as having distinct traits from the other previously discovered fossils, eliciting a new species known as Shri devi in 2021. Shri devi was another dromaeosaurid theropod, Distinguished from Velociraptor mongoliensis based on a weak fourth femur bone or trochanter, a trait it shares with all other dromaeosaurids, and a deep anterior bone depression or pedicular fossae. It is also the sister taxon of Velociraptor mongoliensis due to fossil evidence, meaning it shares many anatomical similarities and may have lived much the same way as Velociraptor. Tooth-bearing upper jaw bones or maxillae and bones on the eye socket or lacrimal bones, recovered in 1999 by the Sino-Belgian dinosaur expeditions, were found to pertain to Velociraptor. This proved to be an exciting and surprising discovery for scientists, as they identified the bones as not pertaining to the type species Velociraptor mongoliensis. Renowned Belgian paleontologist Pascal Godefroy, who was also responsible for the discovery of Velorotitan, and his colleagues named these bones Velociraptor osmolskae as a homage to Polish paleontologist Halska Osmolska in 2008. Halska Osmolska was experienced in Mongolian dinosaurs, describing Elmisaurus, Borogobia, Bagaceratops, and Barsboldia. Her work is paid homage to with this species name. Jurassic Park got everyone thinking Velociraptor was a bloodthirsty, giant, scaly predator, when in reality it was the size of a turkey, a mid-sized dromaeosaurid with adults measuring up to 6 feet 9.5 inches or 2.07 meters long, 1 feet 7.5 inches or 0.5 meters high at the hip, and weighing up to 33 pounds or 15 kilograms, though there is a higher estimate of 43.5 pounds or 19.7 kilograms. The skull, which grew up to 10 inches or 25 centimeters long, was less robust than that of the Jurassic Park raptors, though still similar to the skull of Deinonychus. It was uniquely upcurved, hollow, or concave on the upper surface, and curved or convex on the lower. The jaws packed 26 to 28 widely spaced teeth on each side, each more strongly serrated on the back edge than the front. Velociraptor, like other dromaeosaurids, had a large hand, or manus, with 3 strongly curved claws, which were similar in form and flexibility to the wing bones of modern birds. This is among the many similarities to modern birds, and when seeing birds nowadays, we can appreciate these similitudes: gentle, beautiful, and diverse. Simply imagining a prehistoric shoebill known to feast on baby crocodiles, or even a prehistoric chicken or turkey, is something that is simply fascinating, as we can see many parallels. If we were to see Velociraptor nowadays, it would appear to us as essentially a weird-looking bird. The first of the 3 digits was the shortest, with the second digit being the longest. The structure of the wrist, or carpal bones, prevent pronation of the wrist and force the hands to be held with the palmar surface facing inward, or immediately, not downward. This means dinosaurs were not slappers, but clappers, and were unable to pronate their wrists, as incorrectly portrayed in the Jurassic Park franchise. The first digit of the foot, as in other theropods, was a small dew claw. However, whereas most theropods had feet with 3 digits contacting the ground, dromaeosaurids like Velociraptor walked on only their 3rd and 4th digits. The second digit, for which Velociraptor is most famous, was highly modified and retracted off the ground. The relatively large sickle-shaped claw could grow to over 2.5 inches or 6.5 centimeters long. This trait is typical of dromaeosaurid and troodontid dinosaurs. As in other dromaeosaurs, Velociraptor tails had long bony projections, or presygapophyses, on the upper surfaces of the vertebrae, as well as ossified tendons underneath. The presygapophyses began on the 10th tail vertebra, or caudal vertebra, and extended forward to brace 4 to 10 additional vertebrae, depending on the position of the tail. Paleontologists once thought this was employed to fully stiffen the tail, forcing the entire tail to act as a single rod-like unit. Nonetheless, at least one specimen has preserved a series of intact tail vertebrae, curved sideways into an S shape, suggesting that there was considerably more horizontal flexibility than once thought. This discovery influenced many depictions by paleo artists and proved the Velociraptor was more versatile than once believed. Fossils of dromaeosaurids, more primitive than Velociraptor, are known to have had feathers covering their bodies and fully developed feathered wings. these may have been used to stay warm. The fact that the ancestors of Velociraptor were feathered and possibly capable of flight had long suggested to paleontologists that Velociraptor wore feathers as well, given even flightless birds today retain most of their feathers. This was an idea scientists debated throughout the decades up to Jurassic Park, with feathers in dinosaurs not being widely accepted during the release of the original 1993 Jurassic Park. Fortunately, more evidence has come to light, and scientists now know Velociraptor is one of the dinosaurs that without question had feathers. It was 2007. Paleontologists were uncovering bones from Mongolia, and a mysterious structure was present in the bones. Scientists then reported these structures to have been quill knobs on a well-preserved Velociraptor mongoliensis forearm, confirming the presence of feathers in this species. These bumps on bird wing bones show where feathers anchor, and their presence on Velociraptor indicate that it too had feathers. This discovery, among others, was crucial to the understanding of feathers in dinosaurs, and essential to understanding evolutionary relationships between dromaeosaurs and similar dinosaurs. According to paleontologist Alan Turner, a lack of quill knobs does not necessarily mean that a dinosaur did not have feathers. Feathers were diverse, with some being fuzzy, others to stay warm, and others being similar to spikes, meaning feathers were less like typical feathers in birds nowadays. Flamingos, for instance, have no quill knobs, yet do possess feathers. Finding quill knobs on Velociraptor proved that it definitely did have feathers. This is something paleontologists had long suspected, but no specimen had been able to prove. Co-author Mark Norrell, curator in charge of fossil reptiles, amphibians, and birds at the American Museum of Natural History, also stated, "The more that we learn about these animals, the more we find that there is basically no difference between birds and their closely related dinosaur ancestors like Velociraptor. Both have wishbones, brooded their nests, possess hollow bones, and were covered in feathers. If animals like Velociraptor were alive today, our first impression would be that they were just very unusual looking birds." This idea will change the public's perception of dinosaurs in the coming decades as less like scaly crocodilian lizard-like creatures and more bird-like creatures. The presence of quill knobs on Velociraptor confirms it bore modern-style wing feathers. The forearm specimen on which the quill knobs were found, specimen number IGM-10981, represents an animal 4 feet 11 inches or 1.5 meters long that weighed 33 pounds or 15 kilograms. Based on the spacing of the 6 preserved knobs in this specimen, the authors suggested that Velociraptor bore 14 secondaries or wing feathers stemming from the forearm, compared with 12 or more in Archaeopteryx, 18 in Microraptor, and 10 in Rhodonephus. Each of these were very unique and intriguing dinosaurs with effective adaptations. Scientists stated that this type of variation in the number of wing feathers between closely related species is to be expected, given similar variation among modern birds. The comparison of dromaeosaur traits with those of modern birds is a fruitful exercise that provides more evidence for how they were rather similar in many ways. Scientists, including Turner and colleagues, interpreted the presence of feathers on Velociraptor as evidence proving that the larger, flightless Maniraptorans did not lose their feathers secondarily due to larger body size. They also noted that quill knobs are not common in flightless bird species today, and their presence in Velociraptor, thought by scientists to have been flightless due to its relatively large size and short forelimbs, is evidence that the ancestors of dromaeosaurids could fly, making Velociraptor and other large members of this family secondarily flightless. However, scientists have also posited that it is possible the large wing feathers inferred in the ancestors of Velociraptor may have been used for functions other than flight. The feathers of the flightless Velociraptor had many interesting functions, possibly being used for display, for covering their nests while brooding, or for added speed and thrust when running up inclined slopes. Odds are that the feathers on Velociraptor would have provided insulation, allowing it to maintain a high metabolism, an essential requisite for a very agile and active hunter. This function goes hand in hand with the discovery of dinosaurs as active, warm-blooded creatures during the dinosaur renaissance in the late 1960s that proved dinosaurs were not slow, sluggish, inactive animals. Additionally, Velociraptor lived in a desert-like landscape, with dunes covering the arid landscape and the feathers providing extra protection against the cold nights that are often associated with such environments. Other scientists have also speculated that the feathers may have been used for display, and specimens may have presented sexual dimorphism, with females having a drab, pale coloration and males having flamboyant, colorful feathers to attract these courting females, and this might in fact have been possible. You might have been wondering, what is the explanation behind the pose in the fighting dinosaur specimen? Well, scientists have long been thinking about possible explanations for this fossil, given the intriguing conditions it was preserved in and the almost perfect quality of preservation. Because it was lying on the floor, with its feet directed to the prey's abdomen and throat areas, odds are that the Velociraptor was probably not scavenging. This provides evidence for non-avian theropods as active predators and not strict scavengers, a discovery that formed ripples throughout the paleontological community. Initially, it was hypothesized that the two animals drowned. In spite of this belief, given the animals were preserved in ancient sand dune deposits, it is now thought that the animals were buried in sand, either from a collapsing dune or in a sandstorm. Both of these options would have been a tragic death for both of the creatures, buried in sand and unable to escape or move, frozen in time for millions of years. Burial must have been extremely fast, judging from the lifelike poses in which the animals were preserved. Parts of the Protoceratops are missing, which some scientists have posited as being evidence of scavenging by other animals. Comparisons between the scleral rings of Velociraptor, Protoceratops, and modern birds and reptiles indicates that Velociraptor may have been nocturnal, a tiny terror in the night, while Protoceratops may have been cathemeral, active throughout the day during short intervals, and as actual animals do, resting and taking a break from the hard days under the bright sun, suggesting that the fight may have occurred at twilight or during low light conditions. The slashing hypothesis was tested during a 2005 BBC documentary, The Truth About Killer Dinosaurs. In the show, an artificial Velociraptor leg with a sickle claw was made, and a pork belly was used to simulate the dinosaur's prey. Though the sickle claw did penetrate the abdominal wall, it was unable to tear it open, indicating that the claw was not used to disembowel prey. This means that the terrifying, alien-like raptors of Jurassic Park would probably not have been able to pierce through the skin of its victims. Remains of Deinonychus, a closely related dromaeosaurid, have commonly been found in groups. Deinonychus has also been found in association with the larger ornithopod Tyrannosaurus, which has been cited as evidence of cooperative or pack hunting. However, the only convincing evidence for social behavior of any kind among dromaeosaurids comes from a Chinese trackway, which shows 6 individuals of a large species moving as a group. This, nonetheless, means we would need greater evidence to rule out this idea completely, or to prove it. As of now, we cannot confidently say that dromaeosaurs hunted in packs. Additionally, although many isolated fossils of Velociraptor have been found in Mongolia, none were closely associated with other individuals. Therefore, while Velociraptor is commonly depicted as a pack hunter, as in Jurassic Park, there is only limited fossil evidence to support this theory, for dromaeosaurids in general and non-specific to Velociraptor itself. Dromaeosaur footprints in China suggest that a few other raptor genera may have hunted in packs, but there have been no conclusive examples of pack behavior found as of yet. 2011, Denver Fowler and colleagues suggested a new method, one that might change the portrayal of dromaeosaurid behavior. They suggested a way in which dromaeosaurs, like Velociraptor and similar dromaeosaurs, may have captured and restrained the prey. This model is known as the Raptor prey restraint model of predation. It proposes that dromaeosaurs kill their prey in a manner very similar to extant accipitured birds of prey like hawks, eagles, kites, harriers, and vultures. They would leap onto their quarry, pin prey down under their body weight, and grip it tightly with the large sickle-shaped claws. Like accipiturids, the dromaeosaur would then begin to feed on the animal while it was still alive, and prey would die from blood loss and organ failure. This idea is mostly based on comparisons between the morphology and proportions of the feet and legs of dromaeosaurs to several groups of extant birds of prey with known predatory behaviors. Paleontologist Denver Fowler found that the feet and legs of dromaeosaurs most closely resembled those of eagles and hawks, mostly due to having an enlarged second claw and a similar range of grasping. However, the short metatarsus and foot strength would have been more similar to that of owls. The raptor prey restraint method of predation would be consistent with other aspects of Velociraptor's anatomy, like the seemingly weird jaw and arm morphology. The arms, which could exert a lot of force, but were likely covered in long feathers, may have been used as flapping stabilizers for balance while atop a struggling prey animal, along with the stiff counterbalancing tail. The jaws, thought by Fowler and colleagues to be weak, would have been useful for row saw motion bites similar to the modern-day Komodo dragon, which also has a weak bite to finish off its prey if the kicks or other methods of predation were not powerful enough. These predatory adaptations working together may also have implications for the origin of flapping in parabians, a widespread group of theropods from the late Jurassic period, including dromaeosaurids, Scancoriopterigids, Anchiornithids, and Troodontids. I was able to get in touch with Denver Fowler, and he mentioned that RPR is not exactly indicative of convergent evolution between dromaeosaurids and accipitrid birds of prey, and this is because different aspects of foot proportions seen in birds of prey can be linked to slight differences in their predatory strategy. The foot morphology of these predators is affected by the 4 steps a predator must undergo to eat prey: finding, catching, immobilizing or killing, and consuming. These steps affect foot morphology in different ways depending on each type of bird of prey, with trade-offs along the way. Analysis of the endocranium of Velociraptor indicate that it was able to detect and hear a wide spectrum of sound frequencies, from 2368 to 3965 Hz, and this would help it track prey with ease. Moreover, the endocranium examinations also further cemented the theory that the dromaeosaur was an agile, swift predator that used various hunting methods to restrain, track, and kill prey, and whose adaptations proved to be effective for millions of years. Fossil evidence suggesting Velociraptor scavenged also indicates that it was an opportunistic and actively predatory animal, feeding on carrion during times of drought or famine, if in poor health, or depending on the animal's age. This would mean Velociraptor would have a range of food options and methods of predation, utilizing each when necessary. In 2010, paleontologist David Hone and colleagues published a paper on their 2008 discovery of shed teeth of what they believed to be a Velociraptor, near a tooth-marked jawbone of what they thought was a Protoceratops, in the Bayan-Mandahu Formation. These paleontologists concluded that the find represented a large-stage carcass consumption by Velociraptor, as the predator would have eaten other parts of a freshly killed Protoceratops prior to biting in the jaw area. This added to the pool of evidence, including the fighting dinosaurs fossil, that proved Protoceratops was part of the diet of Velociraptor. In 2012, David Hone and colleagues published a paper that described a Velociraptor specimen with a long bone of an Asdarchid pterosaur in its gut. Paleontologists interpreted this as showing scavenging behavior and would once again prove the plethora of ways for these fascinating dinosaurs to attack and feast on unfortunate prey. Velociraptor was probably warm-blooded, given it required a significant amount of energy to hunt. Modern animals with feathery or furry coats, like Velociraptor had, are typically warm-blooded, since these coverings function as insulation. However, evidence has also piled up about bone growth rates in dromaeosaurids and some early birds that suggest a more moderate metabolism compared with most modern warm-blooded mammals and birds. The kiwi has been compared by scientists and proven to be similar to dromaeosaurids in anatomy, feather type, bone structure, and even the narrow anatomy of the nasal passages, which is usually a prime indicator of metabolism. The kiwi is a highly active, flightless bird with a stable body temperature and a rather low resting metabolic rate, making it a good model for the metabolism of primitive birds and dromaeosaurids. One Velociraptor mongoliensis skull bears 2 parallel rows of small punctures that match the spacing and size of Velociraptor teeth. Scientists think that the wound was likely inflicted by another Velociraptor during a fight. Furthermore, because the fossil bone shows no signs of healing near the bite wounds, the injury probably killed it. One of the tiny raptors was fighting with another belligerent raptor, possibly competing for a scavenged meal or simply to prove their dominance, then punctured the other's skull, leading to injury, proving not cannibalism, but intraspecific competition. The specimen that was discovered with the bones of an Asdarkid pterosaur within its stomach cavity was carrying or recovering from an injury sustained to its ribs. From evidence on the pterosaur bones, which were devoid of pitting or deformations from digestion, the Velociraptor died shortly after, possibly from the earlier injury. This evidence of injuries proves the often tough and challenging life of typical raptors, suffering from injuries and disease just as many animals today, including humans, do. All of the fossil sites that have yielded Velociraptor remains preserve a dry, desert-like environment with fields of sand dunes and only intermittent streams, although the younger barren Goyo environment appears to have been slightly wetter than the older Geodocta. The posture of some complete fossils, as well as the mode of preservation, may show that a number of specimens were buried alive during sandstorm events common to the three environments. This, as explained, may be an explanation for the fighting dinosaur specimen, and provides valuable insights to paleontologists. All known specimens of Velociraptor mongoliensis were discovered in the Geodocta Formation, in the Mongolian province of Mongolia. Scientists have also unearthed Velociraptor species from the slightly younger barren Goyot Formation of Mongolia, though these are indeterminate and may belong to a related genus instead. These geologic formations are estimated to date back to the Campanian stage of the Late Cretaceous, between 83 and 70 million years ago. Velociraptor mongoliensis has been found in many of the most famous and prolific Geodocta localities. The type specimen was discovered at the Flaming Cliffs site, also known as the Bain Zak and Jabarak Uzu, while the fighting dinosaur specimen was found at the Tugrig locality, also known as the Tugrigan Shire. The well-known barren Goyo localities of Kulzan and Kermin Zav have also produced remains which may belong to Velociraptor or a related genus. Teeth and partial remains attributed to juvenile Velociraptor mongoliensis have also been reported from the Bayan Mandahu Formation, a prolific site in Inner Mongolia, China, that is contemporaneous with the Geodocta Formation. Nonetheless, these fossils had not been prepared or studied as of 2008. A partial adult skull from the Bayan Mandahu Formation has been assigned to a distinct Velociraptor species, Velociraptor osmalske. Many of the same genera were present across those formations, though they varied at the species level, possibly due to a natural barrier separating the geographically closed formations. For instance, the Geodocta was inhabited by Velociraptor mongoliensis, Protoceratops andrewsi, and Pinacosaurus grangeri, while the Bayan Mandahu was home to Velociraptor osmalske, Protoceratops helenicorhinus, and Pinacosaurus mephistocephalus. However, given the lack of any known barrier which would cause the makeup of these formations as it is, odds are that those differences indicate a slight time difference. Other dinosaurs known from the same locality as Velociraptor mongoliensis include the Troodontid Saurornithoides mongoliensis, the Oviraptorid Oviraptor Philoceratops, and the Dromaeosaurid Mahakala umnagove. Velociraptor osmalske lived alongside the ceratopsian species Magnerostris dodsoni, as well as the Oviraptorid Macarosaurus leptonicus and the Dromaeosaurid Linoraptor exquisitus. Velociraptor means swift Caesar. This name is derived from the Latin words velox, meaning swift, and raptor, meaning robber or plunderer, and refers to the animal's lifestyle, including running or being cursorial, as well as its carnivorous diet. It perfectly characterizes the behavior of this tiny terror, being active and predatory. It was named by renowned paleontologist Henry Fairfield Osborn in 1924, alongside a few other dinosaurs like Saurornithoides, the bird-like lizard, and Oviraptor, the egg thief. Velociraptor belongs to the kingdom Animalia, the phylum Chordata, the clade Dinosauria, Sauriskia, and Theropoda, the family Dromaeosauridae, the subfamily Velociraptorinae, the genus Velociraptor, and the type species Velociraptor mongoliensis. This part gets a little bit complicated, so bear with me. Velociraptor is a member of the group Dromaeosauria, a derived subgroup of the larger family Dromaeosauridae. It is often placed within its own subfamily, Velociraptorinae. In phylogenetic taxonomy, Velociraptorinae is typically defined as all dromaeosaurs more closely related to Velociraptor than a Dromaeosaurus. However, dromaeosaurid classification is highly variable and hard to pinpoint. Originally, the subfamily Velociraptorinae was erected only to contain Velociraptor. Other analyses have often included other genera, usually Deinonychus and Sauronitholestes, and more recently Sagan. Nonetheless, several studies published during the 2010s, including expanded versions of the analysis that found support for Velociraptorinae, have failed to resolve it as a distinct group, but rather have suggested it is a paraphyletic grade which gave rise to the Dromaeosaurinae. In the past, other dromaeosaurid species, including Deinonychus and theropod and Sauronitholestes langstoni, have sometimes been classified in the genus Velociraptor. Since Velociraptor was the first to be named, the species were renamed Velociraptor antiropus and Velociraptor langstoni. These ambiguities might have in fact been the source for the Jurassic Park Velociraptor, merged with Deinonychus. Nevertheless, the only currently recognized species of Velociraptor are Velociraptor mongoliensis and Velociraptor osmalskae. When first described in 1924, Velociraptor was placed in the family Megalosauridae, as was the case with most carnivorous dinosaurs at the time. This was because Megalosauridae, like Megalosaurus, was a wastebasket taxon, where many unrelated species were grouped together. As dinosaur discoveries increased due to the work of paleontologists on the field and in research, Velociraptor was later recognized as a dromaeosaurid. All dromaeosaurids have also been referred to the family Archaeopterygidae by at least one author, which would, in fact, make Velociraptor a flightless bird. Here are the results for the Eudromaeosaura phylogeny based on the phylogenetic analysis conducted by paleontologists Phil Currie and David Evans in 2019. Surprisingly enough, heavy-built animals like Achillobator and Utahraptor were recovered in the Velociraptorinae. Two species are currently recognized, although others have been assigned in the past. The type species is Velociraptor mongoliensis, named after its country of origin, with fossils of this species having been discovered in Mongolia. A second species, Velociraptor osmalskae, was named in 2008 for skull material from Inner Mongolia, China. It was a carnivore, with evidence indicating that it may have feasted on Protoceratops and even as dark as pterosaurs. Adults measured up to 6 feet 9.5 inches or 2.07 meters long, and 1 feet 7.5 inches or 0.5 meters high at the hip, the size of a turkey. Fictionalized in Jurassic Park as much larger, though inaccurate. These tiny, active terrors weighed up to 33 pounds or 15 kilograms, though there is a higher estimate of 43.5 pounds or 19.7 kilograms. Velociraptor lived in the barren Goyo and Jadokta Formation of what is now Mongolia, East Asia. It lived during the Campanian of the Late Cretaceous, 75 to 71 million years ago. Fossil representation includes over a dozen fossilized skeletons, including the famous fighting dinosaur specimen known as GIN 125, IGM 181, and IGM 182. Velociraptor boomed in popularity with their role as vicious and cunning killers in the 1990 novel Jurassic Park by Michael Crichton and its 1993 film adaptation directed by Steven Spielberg. The raptors portrayed in Jurassic Park were actually modeled after the closely related dromaeosaurid Deinonychus, and also other dromaeosaurids like Achillobator and Utahraptor. Paleontologists in both the novel and film excavate a skeleton in Montana, far from the Central Asia range of Velociraptor, but characteristic of the Deinonychus range. Crichton used the controversial taxonomy proposed by Gregory S. Paul to justify the name choice, even though the raptors in the novel are at another point referred to as Velociraptor mongoliensis. Crichton met with the discoverer of Deinonychus, John Ostrom, several times at Yale University. To discuss details of the animal's possible range of behaviors and appearance, Crichton at one point apologetically told Ostrom that he had decided to use the name Velociraptor in place of Deinonychus because it was quote-unquote more dramatic. This, however, has unfortunately perpetuated many misconceptions and myths about Velociraptor. According to Ostrom, Crichton stated that the Velociraptor of the novel was based on Deinonychus in almost every detail, and that only the name had been modified. The Jurassic Park filmmakers also requested all of Ostrom's published papers on Deinonychus during production. They portrayed the animals with the size, proportions, and snout shape of Deinonychus rather than Velociraptor. Production in Jurassic Park began before the discovery of the large Dromaeosaurid Utahraptor was made public in 1991, but as Jody Duncan wrote about this discovery. Later, after we had designed and built the Raptor, there was a discovery of a raptor skeleton in Utah, which they labeled a super slasher. They had uncovered the largest Velociraptor to date, and it measured 5.5 feet tall, just like ours. So we designed it, we built it, and then they discovered it. That still boggles their mind. Spielberg was particularly pleased with the discovery of the Utahraptor because of the boost it gave to the raptors in his film. Spielberg's name was briefly considered for the naming of the new dinosaur. In reality, Velociraptor, like many other Maniraptor and theropods, was covered in feathers, was the size of a turkey, and did not slash but rather attempted to pierce the neck. Given their popularity, they have been featured in all the Jurassic Park series movies, especially in the 2015 Jurassic World, where they are known not to attack people and are trained to protect them, named Blue, Delta, Echo, and Charlie by their trainer Owen Grady or Chris Pratt, and the 2018 Jurassic World Fallen Kingdom, with Blue as the only survivor. It was also recently featured on Jurassic World Dominion as Beta, with the same inaccuracies present: a scaly covering, pronated wrists, hyper-aggressive monster behavior, and using its claws to stab and disembowel prey. Since the release of Crichton's Jurassic Park, Velociraptor and its relatives have been encountered in numerous books, toy lines, animated films, video games, television series, and documentaries. I will be analyzing their appearance in popular culture and the corresponding inaccuracies as a scientific exercise, not to attack any piece of media. It is featured in the Jerry Pelota book, Who Would Win? Tyrannosaurus Rex vs. Velociraptor, pronating its hands slightly, which would not have been possible, and also without feathers. It makes an appearance in the Walking with Dinosaurs special, The Giant Claw. Nonetheless, Velociraptors were not pack hunters, possessed feathers, and could not pronate their wrists, with those in this episode having essentially broken wrists. Additionally, they did not use their claws to disembowel prey, meaning those in the episode would not have been able to penetrate the skin of the Protoceratops, and odds are that in reality they would target the neck area. In Dinosaur Revolution, a pair hunts an orphan baby Protoceratops, along with an old solitary bull Protoceratops. There is no evidence of pack hunting behavior, and it cannot penetrate the skin of the Protoceratops. It is accurately displayed as having normal, non-pronated wrists and feathers. It also appears in Dinosaur Planet as the main character, a female named Whitetip. These are accurately portrayed as possessing feathers, though inaccurately portrayed as hunting in packs, given lack of evidence for such behavior and as being able to pronate their hands, which would not have been possible. 4 Velociraptors also appear in Scooby-Doo, Legend of the Phanosaur, with great artistic license, bearing pronated wrists, no feathers, and horns, which are all inaccurate portrayals. These were then found to be students in costumes. An additional appearance includes Suit Tycoon with feathers and pronated wrists, and Suit Tycoon 2 with a bigger feather covering, wings, and a straight tail, which may have been a bit more flexible, as evidenced by fossils. It also appears in Parkasaurus, without feathers, a stiff tail, and pronated wrists. They appear in Dinobot from Beast Wars without feathers, too proportionally robust, and with an outdated posture. Hex and Spitter from Extreme Dinosaurs are depicted as reptilian humanoids. Moreover, Velociraptor is featured in a series of high-performance hard disk drives from Western Digital. In 1995, the city of Toronto named its new NBA expansion team the Raptors, with a design largely based on the outdated Jurassic Park Raptors. More recently, it was featured in the spiritual successor to Walking with Dinosaurs, Jon Favreau and BBC's Prehistoric Planet, narrated by David Attenborough, with a great level of accuracy, possessing feathers, non-pronated wrists, and behaving as typical curious animals, using their feathers as part of their predatory strategy. Moreover, their size and proportions are almost perfect, contrasting intensely with the 6.5 feet or 2 meter tall Jurassic Park Velociraptors as turkey-sized dromaeosaurids. However, this depiction includes a bit of artistic license with the portrayal of group hunting behavior, as we are yet to find evidence of this trait. A dromaeosaurid theropod from the Late Cretaceous period, Velociraptor was a mid-sized Mongolian predator. There is direct evidence for feathers in Velociraptor and other dromaeosaurs that has caused ripples through other species and their evolutionary relationships. The quality of preservation of some Velociraptor fossils has revealed insights into the paleobiology of these impressive dinosaurs. Dunes formed a large part of its environment, with a blazing sun during the day and a cold, freezing night. A bipedal predator, it had a long, somewhat flexible tail and distinctive sickle-shaped claws, used for stabbing the arteries and veins in the neck region of prey, given their inefficacy for typical dinosaur skin. Largely due to the Jurassic Park motion picture series, Velociraptor has risen to fame through the Velociraptor in this series. Nonetheless, it was in fact based on Deinonychus, lacks feathers, is too large, and is depicted as a scaly reptilian theropod that hunted in packs, all of which are rather inaccurate traits. However, with science, we can reconstruct these intriguing and unique dinosaurs as possibly having flamboyant feathers, being solitary hunters and unable to pronate their hands. They were active predators that may have scavenged and used their sickle-shaped claws to great effect. A well-known turkey-sized dromaeosaurid and a lightweight bipedal hunter, with many traits similar to those of birds, Velociraptor, tiny, possessing a distinctive sickle-shaped claw, feathered, a swift seizure, significant in paleontology, and a fascinating dinosaur. And with that, thank you so much for joining me in this legendary episode of Dinosaurs Unearthed on Velociraptor. As always, thank you so much for watching. This is Enchiridion. See you next time.